Have you ever just stopped and wondered, what is all this stuff around us really made of? I mean, what are the absolute smallest building blocks of the universe? People have been asking that for centuries. Well, today we're going to dive into the incredible story of how a super routine experiment involving nothing more than a thin sheet of gold foil led to a result so shocking it completely blew up our understanding of the atom.
And really, that's the core question here. This is about so much more than just physics. It's about how science actually works. How just one single unexpected result can bring a whole century of accepted ideas crashing down.
All right, so let's set the scene. We're in the early 1900s. Scientists had just discovered this brand new thing, the electron, a tiny particle with a negative charge. So the big puzzle was, how do we fit this into our picture of an atom?
And this is the elegant solution they came up with. They called it the Plum Pudding model. Just picture it. A big, fluffy sphere of positive charge, kind of like the dough or the pudding, and then you've got these little negative electrons just dotted throughout, like plums or raisins. It made perfect sense. It explained why atoms are neutral, and at the time, it seemed like a really solid theory.
Okay, so here's the most important takeaway from this model. It made a very specific prediction. Because that positive charge was all spread out and weak, any tiny particle you shot at it should just fly right through. Think of it like trying to shoot a tiny BB through a cloud of fog. It's just going to sail on through, maybe getting nudged just a tiny bit, but that's.
So, to basically dot the I's and cross the T's, a physicist named Ernest Rutherford told his assistants, Hans Geiger and Ernest Marsden, to run what should have been a very boring experiment. Seriously, the whole point was just to confirm what they already thought they knew about the Plum Pudding model. No one was expecting any surprises.
The setup was super simple, really. They had this device that would fire these tiny positively charged bullets, called alpha particles, at a sheet of gold foil that was unbelievably thin. And then they had a screen around it that would light up with a little flash whenever a particle hit it. And the prediction? Easy. All the little flashes should show up in one neat little spot right behind the foil. Case closed.
But what they saw was not simple at all. In fact, it was something that, according to the science of their day, should have been completely and totally impossible.
Now, for the most part, the experiment went as planned. The vast majority of those alpha particles flew straight through the foil, but a tiny fraction, about 1 in every 8,000, did something else. And that tiny number, that was about to change everything. And here's what was just so mind-blowing. These particles didn't just get nudged off course a little bit, they ricocheted. Some of them were deflected at these huge angles, and a few even bounced almost straight back where they came from. According to the Plum Pudding model, there was nothing in that atom strong enough to do that. Nothing.
This quote from Rutherford himself just says it all. Can you imagine that? Firing a massive cannonball at a single sheet of tissue paper and having it come flying back and hit you. That's how bizarre, how completely insane this result was. It can only mean one thing. Their entire model of the atom had to be dead wrong.
So Rutherford was faced with this puzzle. For one of those alpha particles to be knocked backwards, it must have run into something incredibly small, incredibly dense, and packed with a really powerful positive charge. And this led him to a completely revolutionary new idea. He came up with what we now call the nuclear model of the atom. He said, forget the fluffy cloud of positive charge. Instead, almost all of the atom's mass and all of its positive charge are squeezed into this infinitesimally small point right at the center. He called it the nucleus. And the rest of the atom? Almost entirely empty space, with the electrons just orbiting way out on the edge. And when you put the two models side by side like this, it all just clicks. With Plum Pudding, the charge is all weak and spread out, but with the nuclear model, all that positive charge is concentrated into a powerhouse nucleus. This suddenly made perfect sense of the results. Most of the alpha particles would fly right through the empty space and miss the nucleus completely. But every once in a while, about one time in 8,000, a particle would get too close, get hit by this massive repulsive force, and get thrown backwards. The impossible was suddenly possible.
But you know, in science, a brilliant idea is just the beginning. A truly great theory has to do more than just explain something after the fact. It has to make specific predictions that you can actually go out and test, and Rutherford's model did just that.
See, Rutherford didn't just draw a new picture of the atom. He worked out the math. He created a precise formula that could predict exactly how many particles you should expect to see scattering at any given angle. It was a bold, mathematical claim about how reality worked.
So Geiger and Marsden went back to the lab, and they tested every single variable. The theory predicted that a thicker foil should cause more scattering. Did it? Yes.
It predicted that using heavier metals would increase scattering. Did it? Yes. It said that faster particles should scatter less, and they did. Every single prediction, no matter how specific, turned out to be true.
And this right here, this is the final beautiful proof. The solid line on this graph is what Rutherford's mathematical formula predicted the result should be. The little dots, that's the actual real-world data that Geiger and Marsden painstakingly collected. It's a perfect match. I mean, look at it. The theory didn't just explain the weird result, it predicted it with absolute stunning accuracy.
So that one single, shocking 1 in 8,000 rebound, the event that seemed so impossible, became the very cornerstone of our new reality. The atom wasn't a plum pudding after all. It was a miniature solar system with nearly all its substance packed into a tiny, powerful nucleus at its heart.
And it really leaves you wondering, doesn't it? What theories do we all just accept as fact today that might be our own modern-day plum pudding? What unexpected little flash on a screen? What 1 in a million result is waiting in a lab somewhere to completely change the way we see the universe?